Hello everyone, this is Praveen Kumar. In this particular presentation, I am going to discuss about high-level architecture of Informatica Repository Service. Agenda for this presentation is user-level understanding of repository service, high-level architecture of repository service, then mid-level architecture of repository service, and there would be one repository service state diagram. So user level understanding. In Informatica, a user can actually execute a workflow with the help of integration service. That workflow can be executed with the help of integration service or with the help of command line client like InfraCMG. We have different clients as well, like Repo Manager, Repository Designer, Monitor, and other tools. All these tools interacts with one particular process, which is known as Repository Service Agent. This is the agent, this is the rep service which directly talks to the database. There is one single process named rep agent process in each repository. This repository agent actually provides the persistence layer for storing and retrieving the metadata, repository metadata. Integrity of the repository metadata is maintained by providing transactional support for each request. Any request for accessing the metadata will be done only via the repository service agent. Repository service agent monitors and notifies metadata operations as well. So repository database, it's a relational database schema which is used by the repository service to persist the metadata. Repository service which manages the repository database has been implemented as a three-tier architecture. Repository service is an active-passive model. Like if you have multiple nodes, so repository service can run in each node, but only one repository service will be active at a given point of time. Rest all will be in passive. In case of failover, any passive repository service will become active. PCSF ensures that if the current repository service process fails, a backup service process is started. There is a repository client interface is given to access and talk to the repository service. Further, on the similar lines, there is a concept of local data repository. So in this image we can see there is a Power Center clients which are talking to the local data repository service which talks to the repository database. In the same way, we can have one more LDR, like local data repository, and these two actually can be configured for keeping the global data repository. So global data repository is kind of bridge between the two local repositories. So Power Center repository is a relational database that stores metadata used by Power Center server, tools, and other extensions. Repository is implemented as a three-tier architecture, as I told you. And repository service provides a rich set of services for effective handling of metadata. Repository service supports distributed sharing of metadata as well. So this is the high-level architecture. Informatica Services Platform and the repository agent services. So repository agent RA is the process that services the repository. It's a multi-threaded server built with the ACE framework. This repository agent is the gateway for any access to the repository metadata from the database. At any point of time, there will be only one instance for this process alive. Repository agent provides transactional semantics to maintain the integrity of the repository metadata. It monitors and notifies metadata operations. It provides high recovery, high availability, and resilience. In a domain, we can have multiple repository services configured with different repository databases. So each repository service would be associated with a particular repository database, and it is going to serve the client's requests. So this is the repository service mid-level architecture, where repository agent is being shown in a couple of blocks. It's not a very low-level architecture. So this particular architecture, I assume that you understand the basic architecture of repository service under PCSF framework. So repository agent is the workhorse or workhouse of repository service. In PCSF terms, repository agent is a service process. So this is repository service mid-level architecture, where repository agent is being shown in the form of blocks. This is not a low-level design. So I can say repository agent is the middleman between the repository clients and the repository database. Repository clients actually connects to the repository agent via the repository agent's host and port number. There is a connection pool, connection manager. This is on the client side, which actually creates a TCP/IP communication between client and the repository service through connection manager. So client connection to this repository agent is a persistent connection. Once connected, the connection remains open until it is explicitly closed. A repository client may open one or more connections to a repository agent. This connection is actually a proprietary protocol over TCP/IP network. This connection uses synchronous request and reply model. Request is one message, reply is 0 or more messages depending on the specific request. Client connection is encapsulated in the repository client library. It provides Repository client library provides APIs to connect, fetch, insert, and do more. With the help of these APIs, repository clients can talk to the repository agent. Some APIs are available in Java as well, these repository client libraries. These APIs are made of on the request and reply mode. Repository code has a template for writing APIs as well. There are multiple threads which gets created when repository service agent gets started. These are called internal threads. So there are many categories of these threads. Like we have repository service has main thread which actually listens for new client connections. Repository agent has worker threads which handles new client connections and it does more activity as well. Repository service has database pool threads which manages database pools, and repository agent has maintenance threads as well which handles certain tasks related to HA, heartbeats, and notifications. Then we have a very big module inside the repository service which is called as a summary tree. So why do we need a summary tree in repository service? So this summary tree is actually on both the side, on the client side and at the server side, both. So at the client side, why do we need this summary tree? This is for speed up fetching of metadata objects for browsing purposes. So that's why we keep summary tree at client side. The information is a browse object is a subset of the complete object. It lies inside the client side process memory. Summary tree is cached and refreshed only on demand on the client side. Okay, so why do we need the summary tree on the server side? Same reasons. At the server side also, this is used for speeding up the client's metadata object browsing. Repository server's object tree is guaranteed to be the latest at all the time. This particular summary tree is cached into the memory for faster execution. The repository service lock manager uses this tree for implementing locking. Repository agent has a module named as lock manager. The lock manager is an in-memory server-side entity that ensures a consistent view of all repository objects. The lock manager uses the summary tree to implement summary tree based locks. Locking semantics changes whether the high availability feature is on or off. So when HA is off, in that case, locks are only maintained in repository server memory. When HA is off, in case of client crashes, server automatically releases all the locks held by that particular client. If HA is off, if the repository service crashes, then it is the responsibility of the client to reacquire all of these locks. Now this locking semantic changes when high availability is on. When high availability is on, locks are maintained in memory and also persisted in the repository database. When high availability is on, in case of client crash, server does not release these logs up to the resilience timeout. In case of high availability on, if the repository server crashes, then all the logs are read from database and populated back into the memory. There are typically two kinds of logs. One is client logs and another is internal logs. Client logs are of three types: read intent log, write intent log, or execute log. Internal logs are kind of transparent to the client. It is used during save or fetch of the operation. Internal logs are shared logs or exclusive logs. Internal logs can be obtained at the granularity of a single metadata object. In a thread, if a thread has an exclusive lock on the object's node, it means that only that thread can read and write to that node. Internal locks can block each other. There are many other modules like database pool and the ODL also available. Database pool is responsible for maintaining a database connection. It maintains pool of connections which can be used by the repository service for fetching any information from the database. ODL layer is like, it is a layer which makes repository agent to use any kind of database, whether it is an Oracle database or it's a DB2 repository database or SQL Server repository database. ODL layer makes sure the queries which are being formed against the repository database are fine. There is no configuration required for different type of repository database. So as I explained, PowerCenter repository is a relational database that stores metadata used by PowerCenter server, tools and extensions. Repository is implemented as a three-tier architecture. Repository is one of the administrator-defined services under PCSF. As I told you, it can work only in the active passive mode. PCSF redirects clients' request to current service processes. State diagram of repository service. Repository service can run with or without repository contents. So how it is? So I have created the repository service and currently it's not running. So from not running, I can directly remove the repository service and go to the end state. But now suppose from not running, when I enable the service, so it can either go to the without content or it can go to the with content repository. So now suppose I'll discuss about from not running. If I enable the service where it goes to the running without repository contents, so if any other request comes, those requests would be rejected because there is no content, there is no repository content. So from here you can directly go create, copy or restore repository content, so that you will come into this state where repository service is running with repository contents. From here you can delete the repository content and directly come back here where repository service is still be in the running state but without content. Okay, now I'm here running with repository contents. If any other request comes, that would be honored because you have repository content. But at this point of time, if your request has come for creating, copying or restoring the repository content, that would be rejected because you already have repository content. You cannot restore again a new repository content. Rather, you can go for deleting the content. When you delete the content, you will come in this state. So this is the basic state diagram of a repository service. So as I told you, repository service is responsible for creating, maintaining and providing services for metadata information. Repository service can come in two different aspects, LDR and GDR, local data repository and global data repository. Repository service can only have access to the repository database, nobody else. In PowerCenter, no any client, PowerCenter client can connect to the repository database directly. It has to connect through the repository service. Repository service is a multi-threaded native application. Hope this presentation has given you high-level architecture of repository service. Thank you for being with me.